So hello everyone, in the last session we have seen the two further more cases in the second case, that is where the velocity is perpendicular to the magnetic field, and we have taken the illustration on the calculation of position vector of a particle when the velocity is perpendicular to the magnetic field. Now we will continue our discussion more on this, and now we are going to discuss about the third case, that is a very favorite case of NEET point of view and JEE Mains point of view, that is case number 3. And what is the case number 3? The case number 3 state that this is a case where velocity and magnetic field have an angle theta, having an angle theta. Okay, means now the angle is neither 90, neither 0 nor 180, and now the angle between them is theta. That is a general case. Okay, we will discuss some more cases also, but let us see this case. If you see this case, so let us consider a magnetic field like this. Okay, I am considering a uniform magnetic field because we will talk about the non-uniform magnetic field also, but for now let us consider as a uniform magnetic field is given, and let us consider like there is some charge q having a mass m, and we have given a velocity v, okay, from horizontal at an angle of theta. First my question is that what is the angle between the magnetic field and the velocity? This is my v vector. Okay, what is the angle between the magnetic field and the velocity? What is the angle? Can you tell me? See, the velocity is, if you see, there are the two components of the velocity. One is v cos theta and another one is, that is v sin theta, correct? First you tell me what is the force due to the v cos theta. Okay, v cos theta, the force will be what? Magnetic force. I am asking what is the magnetic force due to the v cos theta? It will be what? It will be what? What is the magnetic force due to the v cos theta? That is my question. So it will be going to be 0. Why? Because if you see the v cos theta is parallel to what? Magnetic field. And I have told you, whenever any velocity is going to be parallel to the magnetic field or anti-parallel to the magnetic field force will be 0 and the path will be a straight line. Okay, the path will be straight line. That is what is going to tell. Okay, but there is also another velocity, that is another first case. Second case is the v sin theta. Now what is about v sin theta? In v sin theta you can see it is perpendicular to magnetic field. If it is perpendicular to magnetic field, then what is the force? Force will be q into v sin theta into b. So this force is not, obviously this force is non-zero. You can see this force is non-zero. Okay, so due to this the motion will be circular path. So what is going to be exactly happen? If you see the path of this particle, if you try to see and understand the path of this particle, so what is the path of the particle you are going to get? If you see the path of the particle will be something like this. See, it is making a circle, but it is also moving forward direction. There is a motion in the forward direction. Why? Which velocities allow it to move in the forward direction? That is v cos theta. V cos theta is taking it to in the forward direction. Okay, and the v sin theta is making the circular motion. So v sin theta making the circular motion and v cos theta take it in the forward direction. It is something like this. Okay, it is something like this. It is something like this. Are you getting the point? So that is how it is going to be do this motion. So this type of path is called helical path. Okay, helical path. And remember, the distance between these two things between these two circular path is something defined called as a this is something called as a very important term, pitch. Okay, pitch. And here if you see here, this pitch is same everywhere. Okay, same everywhere. Okay, and if I ask you what is that pitch value, can you tell me the value of pitch? How will you calculate? Okay, what is the value of pitch? How will you calculate? See, we can simply see the pitch is a distance which is covered in the x direction. So what is the distance covered in x direction? That is velocity v cos theta into time t, correct, in one time period. What is the time period? We know that is what? That is defined as 2 pi by m divided by qb. I have told you initially that is time period is going to be independent of the velocity. If you have remember my lecture, the time period is going to be independent of the velocity. So just use that value here. Just use that value here, correct? Time period is equal to 2 pi into m divided by qb, and you just put this value in this case. So what is the value you will get? Pitch is defined as 2 pi into m divided by qb into v parallel. Okay, similarly if I ask you what is the radius, this radius, because it is making a, suppose the center is here and this is going to be the radius, correct? So what is the radius? Radius is defined as m, remember it is mv sine theta, okay, because that is the velocity you have to take, upon qb. So I can write it as something called m, I can write it as mv perpendicular divided by qb, correct? So this is about the helical path. Okay, this is something about a helical path. Clear? This is something about a helical path. Clear? Any doubt till here? Okay, can I ask you one question? So just you have to remember this case is the combination of the previous two cases which we have discussed. Okay, case number 1 and case number 2. It is a combination of the two cases, and you have to remember two things which is very important here is the pitch and the radius, how you have to calculate, and what is going to be the path. For that, what is a condition that is necessary. Okay, now the next case, next thing, let me ask you one question. Suppose let me ask you one question. Okay, make some space. Okay, so suppose this is my x, this is my y, and this is my z. Okay, correct? Suppose my velocity is given as 3i plus 4j, and magnetic field is given as some b naught into k cap, correct? This is my x, my y, this is my z. Can you tell me what is the path? Can you tell me what is the path of the particle? That is my question. What is the path of the particle? How many of you saying helix? How many of you saying circular? How many of you saying straight line? Okay, you have to tell me, and you have to also justify me with your explanation that why it is circular, why it is helical, or why it is a straight line. How many of you saying it is a helical? How? If you are saying helical, then what is the reason behind it? What is the reason? First you tell me what is the direction of velocity. See, it is 3 meter per second in x direction and 4 meter per second in y direction. So net direction will be something here, correct? It is something which is in xy plane, see, x and y. So this is the my v vector, correct? Something here. What is my magnetic field? Magnetic field in this direction. So what is the angle between velocity and magnetic field? Can you tell me what is the angle? What is the angle between the velocity and the magnetic field? It is still 90 degree. Yes or no? The angle V and B are perpendicular to each other. Still it is perpendicular to each other. So what is the path? What is the path? It is circular. It is not helical. Simple. Because it is perpendicular, it is not having an angle theta. It is a perpendicular. You can see clearly. Velocity is in xy plane, magnetic field in z plane. If you will do V cross B, the force is like this. So that means this is going to do a circular motion like somewhere like something like this. It is going to do the circular motion something like this. Let me show you. It will be a circular motion something like this. Okay. It will be circular motion something like this. Something like in this plane, like this. It will rotate like this, correct? Something like this it is going to do. Okay. This is going to be the house circular motion like this. So it is not a helical path. Okay. Some people have think it is a helical path, but it is not a helical path. Let me make it very clear. It is still a circular motion. Just I have tricked with you by simply giving the velocity in the form of vectors in x and y component. Many people had gone trick in this, but remember here you have to see the angle between the velocity and the magnetic field, and as it is still 90 degree, so obviously the path is going to be a circular motion. Clear? Till here anyone have a doubt? Please let me know, or otherwise you note it down. Just note it down. Completed? Completed? Okay. So let us proceed further. Let me give you one example and you tell me the answer for this. If you have understand the concept, then you will tell me. Okay. Let's make it slightly difficult. Okay, then we will understand more things. Okay. Okay, let's do one thing. Suppose this is my x, this is my y, and this is my z. Suppose the magnetic field in direction like this. It is in x direction. Okay, magnetic field is in this. This is my b vector, correct? Which is given as b naught I cap. Correct. Okay. And suppose this is my velocity. Okay, velocity which is an angle theta. Okay. Now my question is that, and everything is same. Charge q, mass m, velocity is given. Okay, that is given. That is I am not going to question. My question is that what is r of t? Means position vector for this case. First of all, tell me what is going to be the path. The path is going to be helical, correct? So now you have to tell me what is going to be the position vector. Okay, just think for a second and then you tell me what is the answer for this. You have to think it. I am giving you 1 minute, proper 1 minute to just solve it. Try to solve it, give your 100% and try to solve this question. Okay, tell me what is a position vector at time t. Okay, tell me. I'm giving you proper 1 minute. Just use your brain, use your all concepts and tell me what is going to be the position vector of this particle at a time t. I am waiting. I hope you have done. Okay, so let us see. Okay, we can do one thing. Let us break into a two part. See, we will have a two velocity. One is v cos theta, another one is v sin theta. Always whatever concept you have learned, just try to use it. See, first thing is v cos theta is going to contribute anything? No. In circular motion there is a no contribution of v cos theta, so just leave it. Okay, just first we will see only the circular motion. Due to the circular motion, it is going to be rotated in which direction? See, v cross b, v cross b, so magnetic field will be inside, so the motion will going to be in this plane. And what is the plane of that motion? If you will see, this is going to be the yz plane in which it is going to rotate. So I will going to rotate this plane like this, means this is my x, this is my z, so I will rotate like this. So you will get x inside, z here and y here. Okay, so what I am going to do, I am just going to rotate it. Okay, so let me rotate it and let me draw the correct. Just first we will see the circular motion. Okay, first we will analyze only the circular motion, because we know how to analyze the circular motion. So first let analyze that. This is my inside vector and that is nothing but a x vector, correct? And this is my z vector and this is my y vector, correct? These are the vectors are there, and the velocity we have in y direction, that is v naught sin theta, and the magnetic field we will have in x direction, that is v naught, that is given. So v cross b we are doing and we are getting a force in this direction. So what is going to be happen, this is going to do the circular motion like this. Okay, something like this it is going to do. Okay, let me draw it properly for you so that you will understand the things better. It is going to do the circular motion like this. Okay, it will going to do the circular motion something like this. This is going to be the way in which it is going to do the circular motion. Okay, this is how it is going to do the circular motion. It's circular motion only, but it's not look like. Let me draw it properly a little so that you will consider it as a circular motion. Otherwise it not look like a circular motion exactly. I think it's not look like a circular motion. Let me draw it a proper circle. Okay, okay, so it is going to do a circular motion like this. Okay, something like this is going to be happen. It is going to rotate like this. If I will write the suppose this is going to be my radius, obviously. So if I want to write the content, write the position, so at some angle theta, that is omega t, what will be my coordinate? So first I will write the coordinate in y direction, so I will take the component in y direction. What is my position vector? See, at time t, y direction it will be something called m v sin theta divided by qb into what? Sin qb by m into t, correct? Similarly with what is this? This is z, minus z. Remember it is minus z. So in z direction we have minus m v sin theta divided by qb to 1 minus cos of qb by m into t. And what about the x direction? So this is in circle. If you see in the circular way, then you will say, sir, in x direction there is no movement, it will be 0. But you can see in x direction we have one velocity. This velocity will allow the particle to move in the x direction. And as there is no force, so I can write this simply, the position of a particle in x direction will be v cos theta into t. So this is the coordinate. So what is my final r vector? So my final r vector will be what? Can you tell me what is my final r vector? Yes, it will be very simple. If you have noted down, then I can simply say my final r vector will be what? These are the three coordinates. So I can simply say my final r of vector will be x coordinate, that is v cos theta. Theta is simply given into t plus in y direction mv sin theta divided by qb, okay, into sine of qb by m into t into minus mv sin theta divided by qb into 1 minus cos of qb by m into t. Clear? That is the final position vector. It's look very difficult, it's look very big expression, but it is very easy. If you know the proper method, then it's not a like difficult thing, it's not a rocket science. Okay, see, I have promised you with the starting of this course that I am going to cover you and take you each and everything which is going to be taught in any one of the institute from where you can learn. So that is the content which is going to be teach in any one of the institute, which is from where you can go and you can read also. This is the content basically. So I am providing you the best quality of content. Okay, you can use any module of any coaching institute and solve any question. I have no problem. Okay, so this is what we have got the position vector for this. Okay, how you have to analyze? First you have to analyze the circular motion, and second you have to analyze the linear motion. Simple. Okay, clear? Any doubt here? Okay, now we have left with the last case. Okay, this is the second case, then the last case is left. And if we see the last case, just a minute, if we see the last case is a very special case when the v is not constant. See, in all the cases we have taken the magnetic field as constant, but it is not necessary the magnetic field will be constant. Magnetic field cannot be constant also. So for that case, how you have to do? Okay, for that case, how we have to do? So let us discuss that case. In this case, there is a proper way to solve it. If you are interested, I will tell you the way, or if you are not interested, I will not tell you the way. So for, see, basically it is something like this. Suppose this is my region, okay, where we have a magnetic field, or you can say okay, suppose my magnetic field is defined as a function of something. Okay, the function of minus b naught into x into k cap. Okay, means it is a function of x. As my x is changing, my magnetic field is also changing, and the question is very simple. See, suppose there is a particle, and suppose this is my x, this is my y, and there is a particle. Okay, I send this particle with a velocity v naught, correct, and charge q, mass m. So this the magnetic field will be in this which direction? Say it will be inside direction, correct, because as my x is increasing, magnetic field is decreasing, and it is in minus k cap. Means if this is y, this is x, this is y, this will be z, so it is in minus k cap, means it is inside, correct. So if you talk about the path of the particle, how it is going to be like this in this case. See, the particle is going to be, see here we have a force at every point, correct, and this force is not constant, it is changing. So if you will see the path, it will be something like this. Okay, it will be something like this. The path will be something like this, correct. Now my simple question is what? The question is very simple. Now at this point it reaches a some distance that is x max. My question is very simple. You have to tell me what is the value of x max. That is a simple value, you have to tell me. Okay, so for now I am giving you as a homework, you have to calculate what is the x max for this. Okay, so till then, if you have liked this session and you have understand something new, then please like it, share it and subscribe it. Have a nice day. Thank you.